Hello everyone and welcome to the Hartford Chemistry Virtual Open Day for 2020. I'm Claire Vallance. I'm the Physical Chemistry Tutor Fellow at Hartford College, and I teach all of the parts of the course that are related to physical chemistry, which is really, I suppose, the measurement part of chemistry.
Yeah, hello, my name is Fernanda Duarte. I teach organic chemistry for first, second, and next year will be the whole course. And we cover several topics of organic chemistry, starting from the knowledge that you got in high school, going more advanced into the mechanism.
Hello, my name is Mike Laidlaw, and I'm the inorganic chemistry tutor at Hartford. And of course, I teach the whole of the periodic table, which is really exciting.
Hi, and I'm Tom Fay. I'm also a physical chemistry tutor here at Hartford.
Hi, I'm Ian. I'm a second year chemistry student at Hartford.
Great, so now you know who everybody is. I thought we'd start out, I'll give you a little bit of a description of the chemistry course at Oxford and how the college fits into it. So at Hartford, we take between 5 and 6 chemists a year. So if you apply to Hartford, you will come here and you'll be interviewed. And even though you're interviewed by a college, you might be interviewed by Hartford College. You may also be interviewed by another college while you're here. You're actually ranked centrally by the Department of Chemistry. So it's really the chemistry department that's deciding whether or not you get a place. Assuming that you do get a place and you're successful in your application, then you'll come and you'll start your chemistry degree. And I thought you might be interested in what a typical week might look like. So quite a lot of the Oxford chemistry degree is very similar to what a chemistry degree would look like at other universities. So you'll have 10 or so lectures per week in your first year. You'll have practical, so lab sessions, which will either be Monday and Tuesday afternoons or Thursday and Friday afternoons. And those tend to go from about 11 till about 5 on those days. That's much like you would have in other universities. The additional thing that you have in Oxford is you have college tutorials. So these are small group teaching, which you should think of as, I guess, the icing on the cake to your learning. So the idea is that you'll go to the lecture course, you'll have the basic information transfer will happen in lectures. And then you'll go away and you'll try and learn as much as you can about that topic. You'll do the background reading, you'll be given some problems to do, maybe an essay to write. And then when you have the tutorial, that's your opportunity to come and talk through all these ideas with your tutors, clear up anything you don't understand, ask any questions you might have, and delve in more detail into the topic. And the more that you prepare for the tutorials, the more that you will get out of the tutorials. So you would typically have 1 or 2 tutorials a week in the first year, 1 in chemistry, either organic, inorganic, or physical, and 1 in maths. In the first year, you do a maths course, which goes through the whole year, which teaches you all of the maths that you will need to do the rest of the chemistry course. At the end of the first year, you sit prelims exams. These don't count towards your degree, but you do have to pass them to go into the second year. In the second year, things carry on much as they do in the first year, same in the third year, apart from at the end of the second and third year, you have exams that do count. And the exams at the end of the second year count 15%, the exams at the end of the third year count 50%, and then the practical labs that you do count 10%. Now, the thing that's really unique about the Oxford chemistry course is the 4th year. So in the 4th year, you join one of the research groups in the department and you do a whole year of research. There are no courses, no exams, and you will be researching something brand new. You will join one of maybe 80 or so research groups. So you really have a very, very wide choice. And you will be doing something that nobody's ever done before, looking at a problem that nobody's ever looked at before. And lots of our Part 2 students do really, really well. On the day when we're recording this video is actually the day when all of our Part 2 students have handed in their thesis. So it's, it's been brilliant for them to finish that this year. Your Part 2 year is examined by a thesis. So you'll write up a thesis at the end of the year. When I tell people that they have to write a 60-page thesis, they start to panic. But I should reassure you that actually the problem is normally getting your work down to 60 pages, not getting your work up to 60 pages by the time you've spent nearly a year working on it. A lot of our Part 2 students do work that turns out to be really important for science in the future. They will write papers, they will be published, and other scientists will look to their work to decide, and it will guide work that they do. What else do I need to tell you? Maybe a little bit more about college. So all of the tutors have introduced ourselves, and we will get to know you really, really well through your time at Hartford College. That's one of the really nice things about the college system, is that you will have the same tutors all the way through your degree for the most part, and you'll get to know them really well. They'll get to know you really well. We will be able to spot when you're not working to your potential and push you to achieve what we know you can achieve. You might think that's a good thing, you might think that's a bad thing, but we will do our best to give you the best degree result that you can get at the end. I think that's enough of me giving an introduction. So now we're going to do a little question and answer session. So I think Ian is going to grill us with lots of questions, and we will do.
I'll do my best. Okay, so first question is, how does college teaching work at Hartford?
Well, I'm going to take this one on. Claire has already said a little bit about that, but I think I want to talk a little bit about the group size for this one. And at Hartford, there's usually 5 or 6 students being first years, and therefore we would probably have a group of 2 and a group of 3 for tutorials, or if it's 6, then obviously 2 trios. But ultimately, it's the tutor's discretion, really, whether they want to have shorter times and smaller groups, perhaps sort of 1.5 hours long, or whether they want to have a longer session as a class for maybe 2 hours. And that sort of depends on the tutorial topic and whether it's a revision class or a core topic. Sometimes it can be a one-to-one, particularly if a student has some difficulties, or it can be because a student is particularly more able than the others. I've done both in my tutorial experience, because at the end of the day, we as tutors are trying to do the best thing for someone's education. It also depends on personal dynamics. So which students engage better in smaller or larger groups, perhaps, what kind of personalities are involved, and we want basically everybody to get on as best as possible and to bounce off one another in a conversational and helpful manner. It can be a group of 4 sometimes, so the current second years I often see as a group of 4, and that seems to work pretty well. The aim, of course, is for a wholesome experience. So there's no rules really, it just depends on circumstances, tutor discretion, and what works and what doesn't work, and that obviously depends on individual students as well as individual tutors and their styles. So flexibility, I would say, is the key. Tutors should be flexible and students should be flexible and to experiment and see what works best.
Thanks, Mike. You've also done some, you've tutored students from many different colleges. Do you think there's like a big difference in the way different colleges tutor their students, or is it all very similar?
I would say there are no dramatic differences. There are some subtle differences, and they are far too numerous and detailed to go into, but differences might be how big the year group in the college is. So some colleges have a very large year group, maybe 10, or some colleges even 12. Hartford is relatively more smaller groups, really, sort of 6 in total per year group. Schedules can differ from college to college. Sometimes they are very fixed, as in you definitely have organic this week and you definitely have inorganic the following week, etc., etc. And some colleges are more free in that, and I would probably say Hartford is one of the freer colleges in their schedule. And obviously tutors' personalities and styles can vary a little bit from college to college, but on the whole, everybody's doing the same course, so there's no dramatic differences.
One thing that I might add to some of that is just how different tutorials are to, say, classes that you might have had at A level. So in a tutorial, you'll do the work independently beforehand, and it's a chance to review the topic. So unlike in a class at A-level where your teacher is teaching you, that kind of thing is done a lot more by the department in lectures.
Thank you. So I guess a big question a lot of students have is, how are they going to be assessed? So there's two parts. You've got the practical side of the degree and also the academic side. So how do the exams and assessments work, and how much does the practical skills count towards the final grade?
That's a very big question, really, but I can break that down into portions. First year, for example, you have exams to pass at the end of the year to carry on, but they don't formally count towards your degree. And similarly, there are practical experiments, labs that need to be done during the first year as well in order to proceed. So that's sort of like a gate system, really. For the second and third year, the end of year exams do count towards your final degree, and the second year exams are 15%, and you have one exam in each of the three branches of chemistry, physical, organic, and inorganic. The end of the third year written exams are a total of 50%, so they're the major ones, and you would have 6 core papers plus 1 option paper for that. And the practical course in the second and third year is continuously assessed, really, that you need to complete each experiment, have it marked, and a little bit of quiz and answer questions and so forth. And that adds up to a total of 10% for your degree. And then the fourth year, as Claire has already mentioned, really, is your research year, which adds the remaining 25% to your degree. The practical skills, therefore, are an integral part to the course, although in one sense studied separately to the lectures and the academic tutorial component. They are nonetheless very important because as chemists, our laboratory skills, our manual dexterity, our application of principles and working and designing through experiments is a very important scientific skill to have, both if you pursue chemical education or chemical research, or whether you go into industry. All these hands-on aspects are very important, and the Royal Society of Chemistry, rightly so, requires us to have a certain amount of lab hours so that we are a genuine chemistry degree in that respect. Not sure whether I missed anything out there, but
No, that was good.
A couple of things about the practical course, if I can. So there are a lot of practical hours within the degree course, but it's only worth 10% of the mark, and students are often a bit kind of perplexed by this. So it is worth explaining why. So we want the practical labs to be very much a learning environment. We want students to be able to come into the labs, learn how to do practical chemistry, not be afraid of making mistakes, be able to ask as many questions as they like. And that's the main reason why we keep the kind of assessment side of it relatively light, so that, you know, students don't feel like they're being examined all of the time while they're doing the practical labs, so they can really focus on actually learning. And I would also say that the practical course does a lot more than just teach you specific practical skills. It teaches you a lot about problem solving, planning, time management, working with other people. So, you know, there are a lot of really, really important skills that you will get from the labs, in addition to the kind of on paper, I can do a titration kind of skill.
Thanks, Claire. Yeah, that's a really good point, actually, about not being afraid to make mistakes. I think it would be a lot more stressful for me if there was a greater weighting for labs. Okay, brilliant. So moving on to the fourth year, is it possible for you to do your fourth year abroad?
I think I can take this one. Fourth year is definitely kind of the very interesting aspect of the chemistry degree at Oxford, I think, compared to other places. It's where you have the freedom to do research, like real time. And it's allowed you, you can do that in Oxford in the chemistry department, as Claire said, but also you can do one of the terms. So one of the 3 terms, you can do that abroad. And that will very much depend on the project and the supervisor that you will sign in for in the project. So it's not something that you decide independently, but it's something that can be discussed with supervisors, with people in the department early on, so that can be planned. That can also be done in a different department than chemistry. So part of the 80 different groups that you have in chemistry, you may be able to join something with other departments at Oxford or other places. So there are some flexibility there, and very much depend on the nature of the project and the supervisor that will be directly supervising you in the chemistry department at Oxford.
Thank you. So do we as students have the freedom to research absolutely anything we want within the field of chemistry, or is it kind of restricted into
I will say that
level?
because personally here in Oxford, there is so much research going on in so many different areas covering physical, organic, inorganic, medicinal chemistry, etc. So it's pretty much everything in the chemistry, what is like being pushed forward into research in chemistry. So I will pretty much say, yeah, you can explore many different areas, even those that you didn't consider during the 3 previous year or your studies. So definitely it's important when you have to make the decision in 3rd year to explore what is around, which are the possibilities before deciding kind of immediately what to do in the 4th year project.
I think it's fair to say that the some 4th-year research groups are rather more interdisciplinary than their individual sort of parent backgrounds, so to speak, because as research goes forward, boundaries are ultimately eroded between the traditional branches. So it can be, just because you might be doing a part 2 in a particular sub-department doesn't necessarily mean that will be a sort of a hermetically sealed process.
Yeah, I mean, I could add to that. I mean, within chemistry, there are typically about 180 Part 2 projects on offer, so there is plenty of choice. But if you really can't find anything within chemistry you want to do, then you can do a project that has some chemical element to it within physics or materials or earth sciences or biochemistry or you know, other departments. Some people also do Part 2 projects in history and philosophy of science. So probably about 5 or 6 students a year do that. Within my own research group, I have quite close collaborations with materials. So I've had people working both in my lab and in materials. And also I've had people working in my lab and up at the local hospital as well on some projects. So it's very supervisor dependent where you might end up working and what you might end up doing.
And it's very much exploring and using the basic knowledge that you have in the 3 first years to explore kind of very new things. So it's definitely interesting and worth taking the time to see what is around and discovering many areas that maybe you didn't hear about before.
Brilliant, thank you. So is there a lot of opportunity in what courses we can take when we're actually on the degree? Or is it all very core-like material and there's no freedom at all?
Yeah, so I mean, this has been touched on a little bit already, but so it depends what year you're in. So in the 1st year, everybody does the same material. So everybody does physical chemistry, organic chemistry, inorganic chemistry, and also the maths for chemistry course. And this is to kind of get everybody up to the same level. And then in years 2 and 3, you have to do physical chemistry, inorganic chemistry, and organic chemistry. There's a large amount of core material that you have to cover. And for, I think, 1 out of your 10 examined papers in 2nd and 3rd year, you do have options. So there is an options course where you typically choose 3 or 4 different options to do. And these cover a lot of different areas within either physical, organic, or inorganic chemistry, and things that are also kind of on the border between these. Also in sort of years 2 through 4, you can choose to do extra through supplementary subjects, which are actually really interesting. I did a couple when I was an undergraduate, and there are some supplementary subjects within which are more based within chemistry, so things like quantum chemistry or heterocyclic and aromatic chemistry and organic chemistry option. but there are also supplementary subjects a little bit outside of chemistry. So things like history and philosophy of science, pharmacology. And then finally, of course, in your fourth year, you have choice of almost any research topic, as we were just discussing. So there's a mix of a lot of core material in the first 3 years, so that you have a solid foundation in all of chemistry, ready to do some really cool research in the fourth year.
Thanks, Tom. So I think a big question that a lot of applicants will have, and I think I had this as well, is there anything that I can do to make my application stronger? Are there any do's and don'ts?
Okay, I'll take that one to start with, though others may well want to chip in later. So the main thing that we are looking for when we're looking at your applications is we are looking for excellent chemists. And that means we want people who are both good at chemistry and enthusiastic about chemistry and who really, really want to come here and study chemistry. So first and foremost, the best thing you can possibly do is work really hard at chemistry at school and at other relevant subjects. So maths, physics, biology, whichever of those you're doing, you know, get the best grades that you possibly can in all of your exams. That's the very first thing that we'll be looking at. Assuming that you do that, when you're thinking about preparing for interviews, there are certainly things that you can do to help yourself there. So one would be to read widely around the subject, you know, just educate yourself about chemistry and related topics. And people always ask me at this stage, well, what should I read? You know, tell me the 4 books I should read. But that's not really how it works. And I always say to people, and I will say to you now, this is possibly the last chance you will get to choose what you read for quite a long time. So when you come to university, everybody will be telling you what to read. What you should do now is you should read the things that you're interested in, read the things that fascinate you, and you won't go far wrong. So that's one thing you can do is just read widely. I mean, whether that's getting hold of the new scientists and you know, reading that as much as you can, or whether that's finding books on popular science or unpopular science, you know, whatever you like. But, you know, read according to your interests now. Another thing that you can do is you can do some specific practice for your interview. So when you come for interview, you're going to be talking about chemistry. And that's probably something that you haven't had a great deal of experience with doing before. And it's something that you can very helpfully practice. So one way to do this would be to have study groups with some of your friends, you know, so when you're studying for A-levels, preparing for exams, just get together in a group and take it in turns to work through a problem on the board and, you know, explain to your friends what you're doing and answer their questions. That's one really, really good way to prepare for an interview. Something else you can do is, you know, you can pick on various members of your family and try and educate them in some aspect of chemistry, you know, so sit your grandma down and say, right, Granny, today I'm going to tell you all about kinetics. Please ask me as many questions as you can until you understand it. Or, you know, you can sit your dad down and say, right, today we're going to do a spot of organic chemistry. You know, you're about to learn more about chemical reactions than you ever wanted to know. You know, that's a really good thing to do. I mean, you will be talking about chemistry and, well, you know, if your dad or your grandma happen to be chemists, they might ask you some quite challenging questions. But if they're not, they might ask you some really interesting questions that will really make you think. So those would be the main things I would say that you can do to help yourself prepare. I don't know if anybody else has things to add to that.
I mean, I would just say that we look at all we are looking for sort of academic excellence, but we also look at it in context. So we don't expect you all to have 6 A-levels or far from it. We know that, for example, some schools only offer 3 A-level subjects to all of their students. So we are aware of this. So, you know, don't feel you have to be the greatest A-level student in the whole universe to be applying here.
Yeah, no, I often say to people this actually. So, you know, we are not expecting you to be a genius. So get that out of your head, right? Look at the offers. You know, if you're looking at chemistry, some of you may be looking at other subjects. Look at the offer grades for that subject. And if you think you stand a snowflake's chance in hell of getting them, why wouldn't you apply? Why wouldn't you give it a go? Yeah,
absolutely. Yeah.
And also about the kind of getting the answer right is not necessarily the goal in the interview process. So don't feel afraid if suddenly you realize that you don't know the answer to that question, but try to use the knowledge that you have to think how you could answer that particular question. even sometimes having the answer right doesn't mean that you did well at all if you're not able to explain the way that you are thinking or the knowledge that you're using, how you're organizing your ideas in your head. And that is also very important.
Okay, unless anyone else, anything else to add to that? No. So this is very similar. It's more, what sort of stuff would you ask in the interview? And I remember when I was applying, I was nervous that I was going to get asked something that I hadn't actually covered at A level yet, and I might feel at a disadvantage compared to other students.
Okay, well, I would say to you that you should have been worried, because that's pretty much exactly what I tend to do in my interviews. But that's not meant to scare you. So my approach to interviews is that I'm not actually that interested in you being able to tell me lots of facts that you've learned, right? I mean, obviously, I expect that, you know, assuming you're doing chemistry at school, which you should be if you're applying to do chemistry at Oxford, you know, I'd assume that you're fairly well up to speed on everything that you've covered so far in your course. And, you know, I'll be aware that different people will be at different stages in their course, and that people will be doing different courses. Many of you will be doing A levels, some will be doing IB, some will be doing Scottish Highers, some will be doing other qualifications. So we know all of that. So there will be some kind of basic level of knowledge that I expect you to have, but I'm not really interested in you just kind of telling me stuff you know. What I'm interested in is how well can you think? How well can you solve problems? And if I present you with some new ideas, what can you do with those ideas? So what I'll normally do is I'll spend a few minutes teaching you something that I think you probably won't have met before, but it will be something that I think you should be able to understand based on what you've done in your A level or other courses. And then I'll start asking you questions about it. So I might say, well, you know, here's a situation and here's a little bit about it. What do you think would happen if I did this? What do you think would happen if I did that? Here's an equation that tells me something about this system. You know, what happens if I put these numbers in it? Or, you know, can you draw me a graph of how this changes? Or, you know, that kind of thing. And I can do that with lots of different bits of physical chemistry. As a physical chemist, I would want to make quite sure that you can do some maths, right? You don't need to be a mathematical genius. You do need to not be scared of doing maths. And, you know, be happy with the basics, like, you know, rearranging equations and maybe a little bit of calculus and things like this, but nothing more than you should have done at school already. The others may well want to say things now about what they do in their interviews.
Yeah, I would just quickly add that, yeah, the mathematical thing is something we really look for. And in particular, can you apply some of your mathematics knowledge that you've got at A level to a more chemical problem? So can you translate those skills into this slightly different context?
Yeah, I would actually just say as well that as Fernanda, just come back to what Fernanda said earlier, we're not necessarily looking for you to know the right answer. We're looking to see how you think through a problem. And we're not just going to present you with a problem and then kind of sit back and watch you suffer. If we think you're stuck, you know, we'll try and help you and get you started. You can help yourself by telling us what you're thinking. So, you know, if you don't really know the answer or you don't really quite know what we're getting at, you know, you might want to say something like, well, you know, this isn't something I've done and I'm not totally sure about this, but is it something to do with this? And we can either say, yes, it is, or no, it isn't, or no, it isn't, but have you thought about this? Or, you know, we can help you. So the more that you say in your interview, as long as it's kind of somewhat well thought through, you know, the better really. And as I say, you know, sometimes we'll let people go quite a long way down a road to, you know, the wrong answer. And that's not necessarily a bad thing. We'll let them get a certain amount of the way down and then we'll say, well, okay, let's just look at where we've got to. Just have a think about that. You know, do you think that that's right? And if not, why not? And that can be really helpful as well and can steer people back onto the right track. And then the other thing that it's worth pointing out is when we're interviewing you, we're trying to find out how good you are at chemistry, how good a chemist we think you can be. And the way that we're going to do that is we're going to keep asking you harder and harder questions until we find something that you can't answer. Now, it's good for you to know that in advance because you guys will all be the people who've been sitting in class and always know all the answers. And you might find it quite unsettling when suddenly you don't know all the answers. So it's really important that you know that that's going to happen to everybody. So if there's something you can't answer, it doesn't mean you've failed your interview or the world is ending. you know, it just means that we're doing our job properly. So you shouldn't, after the interview, do any kind of post-mortem. Just do your best in the interview and then go and do your next interview, or go home, whichever bit of the process you've got to.
The area of organic chemistry also, I would say, like during this time that you are in school, people tend to learn many rules and tend to come with the correct answer, just saying, I'm following this rule. Try to question that, and that will be very important for practicing the way of questioning during the interview process. Use your A-level studies also as a way to question the rules that you're learning, in particular, for example, organic chemistry.
That's good advice. Always ask why.
Right. Has anyone else got anything else to add? Or okay, I guess I could talk about my interview experience, just because it's probably quite nice to hear a student talk about it. I didn't have any proper practice for the interviews before I came. The only one I had was my head of sixth sat down and basically asked me why I wanted to study chemistry. So I had all these answers in my mind about, like, I don't know, why Hartford, why chemistry, but yeah,
You didn't ask that, sorry.
Yeah. Oh well, it worked out in the end. But yeah, you can't really read too much into the interviews, because I remember with Claire, my interview, I think I got the wrong answer, and then I was told the right answer, and then I still said the wrong answer. And Claire, you told me to just sit back and just take a breather and then come back and re-answer it. So yeah, you can't really read too much into them. You don't really know how you're doing, but it was, yeah, I don't think I felt particularly confident after either of my interviews, but I did all right. So yeah.
Great, okay. Well, I think Ian's run out of questions. I think we may have run out of answers. If any of you have any questions about the chemistry course, you can certainly get in touch with the academic office at Hartford, and they will forward your questions to us and we can answer them for you. But otherwise, I hope you found this little video helpful, and we will all give you a little wave and say goodbye.
Bye.
Bye-bye.